So we're going to look at 16, 17, and 18, condensing. So we're going to write these as one log. You're only allowed to write the word log one time. Most common mistake that I see when it comes to the quotient property, the one where we're dividing, is that people like to write the word log more than one time. And this only happens on this property and only on problems like number 16. So we see the subtraction sign, so we know it's going to be division, right? You guys catch me? Making sense? All right. So we know it's going to be P divided by M. The order counts here. The first letter is your numerator, second one's your denominator. But I'll have students try to write log P divided by log M. Please make sure you understand that when you're condensing, put this somewhere in your notes. When you're condensing, you're only allowed to write the word log one time. So the word log is written one time. And then it's P divided by M. You could put parentheses around that if you want, but it's not necessary. What is the base of this log, since it's not written out? 10. It's a common log. Good. All right, 17. What's going on here with 17? We've got three parts happening, right? Take a look at that problem 17. What happens with the 8 and the 9? Are you looking at problem 17?
Yes.
Okay. What's happening with the 8 and the 9? They're both in the top, but what's going on with them? What do we do with the 8 and the 9? We multiply them. And then what happens with the 2? It's in the denominator, so that's going to be divided, right? So we write the word log one time, has a base of 6. We're going to multiply 8 times 9, and we're going to divide by 2. Bless you. Well, what is 8 times 9? 72. And divided by 2 would make it 36. All right, well, can you evaluate that? Yeah? What is log 36 base 6? 2. Remember, evaluate means find the missing exponent. So that is an exponent of 2. All right, and then finally number 18. We're condensing, so we're going to write the word log one time. Base is 10. It's a common log. I see subtraction, so I know it's going to be a division problem. What's the numerator? Numerator is, everybody, x. Denominator, be careful here. Y squared, yeah, that 2 is going to come around, become the exponent again. All right, now number 19, this is combining all of our properties together. So I'm going to write it out. We've got 4 log x. These are all common logs now. 2 log y minus 3 log z. So what are we going to do with that 4? Yeah, the 4 becomes an exponent. And you are totally allowed to do this, maybe to save a little bit of paper. You can cross out the 4 and make it become the exponent. Cross out the 2, make it become the exponent. Do the same thing here with the 3. That might save another line of writing. Write the word log one time. We're going to multiply x to the 4th and y to the 2nd, and divide z to the 3rd. Now number 20 is already written as one log. So what do you think you're going to do with number 20? You're going to expand, right? You have a couple of options here with number 20. One option is go ahead and raise both to the 4th power and have x to the 4th and y to the 4th. Does that make sense? If you do that, then your final answer would look like this. 4 log x base 3 plus 4 log y base 3. So that could be one of your, that's an option for you, okay? The other option is this. You could actually move the 4 down front first. Now, if you do this, please watch. If you choose to move the 4 down first, then when you break apart the x and the y, you're going to need some brackets here because the 4 needs to go to both the log x base 3 and the log y base 3. Without those brackets or parentheses, if you just have it next to 4 log x base 3 and not inclusive of the y, then you would miss that, right? Because it needs to be to both. It does not matter which way you express it. They both are equivalent statements. Does that make sense? Needs to be one or the other, though. All right. So did anybody take advantage of the opportunity to look ahead at page 496? I was hoping somebody did. I want you to take a look, though, at specifically the problems 22 to 28. We were doing the even problems there. You start with problem 14, but I want you to take a look at 22 to 28 because those are problems we have not discussed yet. This brought me back to my youth because this is how I actually had to work with logs. 496. It's written on your notes. It's your assignment that you have now. So I want to look at page 496, specifically the problem set that's like 22 to 29. I know you just had to do the evens, but in that problem set, they say they give you a value for log 5 as approximately 0.699 and a value for log 15 as approximately 1.176. Now I'm saying that this brought me back to my youth because when I was a kid, our calculators, most of them did not have a log button. And so if I wanted to know what log 15 was, I couldn't just press log 15 on my calculator. We had a log table in the back of our algebra book, and it would give us the value for log 2, log 3, log 4, log 5, log 6. You know, they would list it, and they would give it out to 3 or 4 decimal places. And so when it was time for us to do our log work, we would use our log tables and our properties, and then we would use our calculator to do either add, subtract, multiply, or whatever with those numbers, because we wouldn't have a calculator just to touch the buttons. And so this gives you a little bit of a glimpse of what it was like to do logs without a log button. So this one is limiting you to just using 5s and 15s. That's all you can use to find out what the value, like in number 22, it says, what's log 3? Well, now you guys just have a calculator. You could actually, this is all base 10, you could actually just click log 3. But this isn't wanting you to do that. This is wanting you to only use these values for log 5 and log 15 in order to find out what's log 3. So the question is, how can you use 5 and 15 in such a way that you could get a 3? What can you do to 5 and 15 to get a 3? You can divide, right? So isn't log 3 the same thing as saying log 15 divided by 5? Isn't that the same thing? All right, so that's what they want you to do. Figure out how to use 5s and 15s. You could also use any exponent you want in order to get the number that they give you. All right, so our property then says, oh, it's a quotient, right? It's a division. So when we're dividing, we subtract, right, to expand it out. So we would say that's log 15 minus log 5. The fact that some of you are not writing this down is amazing to me, since this is actually a problem from your homework that you have to turn in. So I'm just kind of shocked that some of you are just blindly sitting there. Okay. So now we just substitute in those numbers. Log 15 is 1.176. And log 5 is 0.699. And this is when you take out your calculator then. And you subtract. So someone get your calculator, tell me what you get when you subtract 1.176 and 0.699. 0.447? Oh, 467, thank you.
477.
Oh my goodness, okay, 477. All right. So if we subtract those two numbers, that's what we get for our value of log 3. So you're not allowed just to hit log 3 on your calculator. I actually want to see that you're using 15 and 5. You're showing that you're dividing it, and then you're using your property to subtract it. Then you're substituting your numbers in, and then you're actually using your calculator at the end just to use for subtraction. All right, so let's take a look at 24.
You always rounded the thousands, please?
Well, we're not rounding.
I know, but like, are the decimals always written?
Yeah, for these, they're out to 3 decimal places, yeah. So what is it for 24? What do they want you to find the log of? 75? Okay, so what can you do with 5s and 15s to get a 75? You can multiply, right? So that's the same thing as saying 5 times 15. So what would you do to expand? You add them, yeah. We use the product rule. And so now we add the numbers. Now that may or may not be exactly what you get if you would just hit log 75. Someone test it out for me. Do you get exactly that? Okay. What about if you hit log 3? You get exactly the same thing? Okay. That's a good way to check your work, right? Now occasionally you might be off by 1,000th, like your number might be off in the thousandths place. And that's how we'll know that you just used your calculator and didn't use the properties. Because you just chose to use your calculator and not the numbers that were given here. Right? So make sure you're using the numbers that were here. And I don't mind doing these with you because, quite frankly, you don't have to use these types of processes now, do you? Because you have a calculator that will do these. But it is a glimpse into what we had to go through before we actually had the log button. How about 26? Because this is an example of when you don't need to use both. What's that finding the log of? 1/5? Okay. So for this one, you don't have to use both numbers, 15 and 5. Now you are allowed to use any exponent you want. You aren't limited to just using 5s and 15s as exponents. You can use any exponent that you wish. So what type of an exponent could you use that would make the 5 become a 1/5? What exponent would do that? You got it. Very nice. Yes. 5 to the negative 1 power is the same thing as 1/5. Very nice. So now let's use our power property. Where does that negative 1 go? It goes in the front, yeah. So it's negative 1 times log 5. All right, well, log 5 has a value. Log 5 is 0.699. And I'm multiplying that by -1, so that is negative 0.699. And then you can check that on your calculator by using log 1/5, okay? And seeing if you get negative 0.699. You get the hang of that? You guys can do one more on your own. You only have one more in that problem set, just number 28. So I'm going to give you guys about 15 minutes to work on the rest of these problems in the set. All right, you have 14 to whatever is listed there. 14 to 56, just the evens. Please ask for help as you need. Try to clear up any misunderstandings before we move on.